So let's assume you've been given a function and you want to find a line that just touches the function but doesn't pass through it, just touching it. That's finding the equation of a tangent. We'll talk about normals in a minute. So let's just jump into an example. So say I've got a function, f of x equals x squared plus, I don't know, 2x. Alright, so I'm going to find the equation of a tangent. So what that roughly looks like, I've got some funky looking graph. I'm going to find a line that touches the graph, okay, just touches it, doesn't pass through it at multiple points, just passes through it at a single point. That is a tangent. Alright, so my function is going to be f of x equals x to the 4 plus 7x. It actually looks something like the thing I've drawn there. And I'm going to find the tangent at x equals 4. So when x equals 4, which is approximately, it's probably up here somewhere, what is the equation of the straight line that just touches the graph? That's what it means, find the tangent at x equals 4. So, I need to know what the gradient of that line is, because don't forget, any straight line will be y equals mx plus c. Oops, just went off the screen. Y equals mx plus c. And if I knew the gradient of the point at which it was touching this graph, I would also know the gradient of the line itself. And to find gradients, we use derivatives. So, f dash x is equal to 4x cubed plus 7. So now I have the derivative function of this, a function that tells me the derivative of this equation at every single point. Now, I want to know the derivative of this loopy equation at x equals 4. So, find f dash 4. That means find the derivative when x equals 4. So f dash 4 equals 4 cubed plus 7. That's 4, 16, 64, 200 and something. 256 plus 7, 263. Alright, so it turns out the gradient at that point, at x equals 4, is very large. It's y equals 263. So now I have this straight line, therefore y equals mx plus c, y equals 263x plus c. So I'm saying I know the gradient of that line is 263. If I know the c value, I'll know everything there is to know about the line. Now, to find the c value, I just need to know a point on that line. Now, I know that the tangent is occurring at 4 something. I just need to know what the something is. So to find out what the something is, I can just sub x equals 4 into, and this is where you have to be careful, I'm subbing x equals 4 into my original equation because I want to know what the original y value is. So into f of x. So f of 4 equals 4 to the 4 plus 7x, or plus 7 times 4. Alright, 4 to the 4 is 256 plus 28. That's going to be 284. 284. So that 284 represents this number here, that y value. 284. Okay, so summarizing so far, I have this funky equation, and I know that when x equals 4, the gradient is 263 at that point on the curvy line, which means that it's also the gradient of my straight line. So y equals 263x plus c. I also know that on my curvy line, it passes through 284, because I subbed that into my original equation, which means that my straight line also passes through 284. So I can sub point 284 into y equals 263x plus c. So when I do that, I get 284 equals 263 times 4 plus c, and I can solve that for c. So c equals negative 768, I believe. Okay, that's really the end of it. I just need to finish tangent to f of x at x equals 4 is y equals 263x minus 768. Alright, that's finding the equation of a tangent. What if you wanted to find the equation of a normal? Might pick that up in the next one.